particle is displaced by a given distance and then left alone, we need to find what is the total distance it will cover until it stops if lambda is given to us. So let's draw the plot and then it will be quite clear what's happening. So it starts at the maximum position, that is L, and then it is left alone, so it will come to the equilibrium, go here, go up again, go here, and like that. So this is the displacement time graph. So now you can see if this distance is L, let's say this distance is A1 from peak to here, and from peak to here this distance is A2, A3, and so on. Then the total distance covered will be L plus A1 plus A1 plus A2 plus A2, like that. So L plus 2A1 plus 2A2 plus 2A3 and so on. So that is the total displacement. So it's not the path of the curve itself. The displacement is just from the y-axis. So don't think that we are talking about the length of the curve. This is the displacement in y-axis. From here to here, displacement is L. From here to here, displacement is A1, this height. Anyway, so this is our total displacement which we need to find. So this A1, when it reaches its peak, can be approximated to amplitude at t/2. Now why it's an approximation? So we have discussed this in 4.70 also, that actual displacement is slightly less than amplitude. So here when the curve reaches its peak, it's not actually touching this envelope curve. So you will get this clarity. So just visit this problem again, 4.70. But this peak is pretty near to the curve. So that's why we have taken this approximation that amplitude at t/2, that is the distance of this green curve from the equilibrium. So we are approximating that to be equal to distance of the peak of this curve from equilibrium. This t/2, by the way, is absolute value. So there is no approximation in that because we are starting from peak to peak. So even though this is not a symmetric sine curve, but if you go from peak to peak, that is absolutely t/2. And then again from this peak to this peak, so that will be again another t/2. So that is 2 times t/2. Then again from this peak to this peak, it will be 3 t/2 and so on. So if you see problem number 4.67, then you will, so if you want to know a bit in detail about the asymmetric nature of the curve, so you can see that problem number 4.67. So here that's not a problem because we are talking about from peak to peak. So the assumption is not in the time, the assumption is in the height. So now let's write the values of these amplitudes. So initially it is L, then twice of A1, so twice of L e raised to power minus beta t/2, because time is t/2, then time is 2 times t/2, then time is 3 times t/2. Beta t is lambda, which is given to us, so we can write this equation as this, and the value of these terms all are less than 1, and it is a geometric progression as well. So this sum till infinity will be 1 upon 1 minus one of the terms. So we simplify that and we will get our answer. All right.